going off of what we're doing last time, we're just going to do some more examples with multiplying radicals. So if I have, I'm going to make you guys feel good before I destroy you. What's the square root of 3 times the square root of 5? Square root of 15. You keep everything inside the square root, right? What if I have the square root of 7 times the square root of 2 minus the square root of 5? What do you get here? What do you think you're going to do? What can you do inside the parentheses? So I can subtract these and I get what? Negative square root of 3? Then you have no idea what you're doing. Are these guys like radicals?
No.
Then how could I add or subtract them? See, you look at that and you're like, oh, I'm just going to put everything together because it looks like it's going to be okay. But you're breaking the rules that we talked about the other day.
Order of operations.
Well, that's what we're saying, the order of operations, but inside the parentheses you can't do anything because they're not like radicals. The only thing you could do here would be to distribute. When you distribute, what do you get? I don't get 14. I get the square root of 14. And when I distribute the other part, I get minus what? I don't get minus 35. The square root of 35, and don't even think about rolling your eyes. There's a big difference between 35 and the square root of 35. Big difference. Can I then subtract these? Why not? They're not like radicals. Remember, addition and subtraction is racist. Right? If they're not alike, they don't go together. These guys are not alike because their radicands are different. You can't do anything else with that. I know that upsets some of you that we're done so soon. That's all you can do.
Even though they have like indexes.
The indices are the same, but if the radicands are not, you can't combine. You cannot add or subtract those. Now, multiplication, I told you, addition and subtraction is racist. Only like things go together. But multiplication doesn't care. Multiplication is like, hey, the more the merrier. So when I multiply these two guys right here, even though the radicands are different, the indices are the same. So according to that product rule for radicals, I can multiply the radicands and get 14. Multiply these radicands, I get 35.
But if the indices were different, then
if this were the cube root of 7 times square roots, initially I couldn't do that, but I could do that. It's not as easy as you would like for it to be, but it can be done. You'd have to look at it in terms of exponents and do some crazy things there. Well, let's not worry about that right now. Maybe that's like a bonus question or something. How about the square root of 5 times the square root of 5 plus the square root of 3? So you would distribute again. That's the square root of 25 plus what? And I just boxed this, right? It's almost too easy. Yes?
Why couldn't you just go ahead and add what's in the parentheses first?
These guys don't have the same radicand. Just like the last example.
Military now, excuse me. So.
okay, I got a question. I'm going to say, because can't you?
Can't I what?
You didn't finish with the
Yeah, I'm not done here. Did I put a box around it?
No. Sorry. Provide
It's like putting a ring on it. If I don't, it's not done. It's not finished. Now, why did I put an equal sign? It's like there must be more I can do here, right?
Square root of 25 is 5.
Word, bring it strong. Square root of 25 is 5. What about the square root of 15? He's just the square root of... Don't say there's no square root of 15 because there is. It's just not pretty. Hey. Don't call it ugly. I just said it's not pretty. Don't call it ugly. What?
I have a question.
Can we break it down like we broke it down yesterday?
Yeah, that's what.
Okay, how do you break down 15? 3 times 5, but are either one of those factors a square? No. No matter how you break this down, the only factor that he has that's a perfect square is the only one that's stupid, which is 1. Well, we can pull a 1 out, whoop-de-doo.
Okay. So there's like another number like 26.
26 is just 2 times 13. That's no good, but if it were 24, you could write that as 4 times 6, then you'd be in business.
Now, if 15 had a power to it, then you could actually do the say 15 squared.
Yes, but yeah.
So that's the final answer.
For this guy, es todo, no más.
Check.
Put el boxo around it. What's the Spanish word for box?
Caja.
Oh, that makes sense. I've got another word in my head, but I don't even know if it's Spanish or maybe it's just somebody's last name. I wasn't trying to be funny, I'm just...
Factual.
Don't hate that. That's a card. I'm just kidding. All right, what are you going to do here? More distributing? Okay, now, when you distribute,
It's like foil.
it's not like FOIL.
Sorry.
FOIL is if you're multiplying a binomial, 2 terms, times another binomial, 2 terms. I do not have 2 terms times 2 terms. I have a single term because this guy is connected through multiplication, times 2 termos.
He tried his hardest.
Yeah, I'm horrible. When you distribute here, what do you get?
I don't understand. You just said you don't distribute like foil.
I'm not foiling. I'm distributing this term to these 2 terms.
I understand that, but
I don't think you do.
Right. Is it 3 and 4 and 2
You
and
did.
2?
Hold on. We need pause 10 seconds for station identification. This is a volunteer radio network. Now,
2.
no, stop. I'm going to ask you to stop right now. If I ask you to do 3x times 4x minus 7y, if I ask you to do that, could you do that?
Yes.
Oh, sure, no problem. What do you get?
12x squared.
Okay, now I want you to stop right there. We're going to finish this in just a moment. Okay, I can't stop you. Go ahead and finish. I know you want to.
Yeah, minus 21xy.
Now, notice what you did. When you, yeah, I know you distributed, you didn't FOIL, did you? When you distributed here, you did the coefficients to get 12, and then you multiply the rest of that to get x squared, because that's what you could multiply and condense together. Now, in this problem here, do the same thing. I'm just multiplying this. That's not FOIL. It's not. No, it's not kinda. Kinda nothing. It's not. No, don't argue.
Okay, you lost me. Trying to over-explain it, you lost me.
Where the 12 and
3 times 4 is 12.
yeah.
Those are the coefficients, basically.
So is it 4?
And you multiply the radicals, and you get the square root of 4.
Yes, that's what I'm saying.
That's not FOIL. I'm losing my mind. Help me.
I was thinking the radicands were going to stay the same because you're multiplying
Then
like
why
terms.
you just saying?
When I multiplied x times x, was it just x? No, it was x squared.
That's only an addition and subtraction that you're allowed to do. as
If you were
well.
just adding and subtracting like terms, then those variable pieces wouldn't change, or those radical pieces wouldn't change. Finish distributing here, what do you get?
Minus 21.
And then you multiply the radicals, and what do you get?
10.
Square root of 10.
Square root of 10. Am I done?
Uh,
Why are you shaking your head no?
oh yeah, 4 can be square rooted.
We can evaluate the square root of 4. What's the square root of 4? So this whole guy right here is equal to 2. Do y'all agree?
So it's 2 times 12.
So what do I get?
24.
You don't know 2 times. So 24 square roots of what?
Nothing.
There's no square root left because the whole square root of 4 gave you 2. There's nothing here. Trick question.
Nothing.
Can I do anything with the square root of 10?
What are you doing?
What do you mean, what am I doing?
Oh, never mind.
The square root of 4 is 2.
Never
This is
mind.
multiplication. 12 times 2 is 24. You guys look very unhappy with me.
Always.
The feeling is mutual. Well, there's no foiling thing. Don't say you had it up until the foiling. Don't even say. Later, you know what? Hold on.
Corrected the
No.
boiling thing.
I didn't-
Yeah, and then you just.
Please don't say that, that makes him angry.
A lot of things make him angry.
Now, wait, so I can do.
Green, that's really obvious, scary.
So I can do 24 minus 21, right?
No,
No.
because there's a coefficient of 2.
If I didn't have that there, I could, but you cannot subtract before the multiplication, so that would be breaking the order of operations. This is all you can do for this problem. If you don't believe me, what if I wrote this? Still more my thought process for things that you're supposed to know. If I have 24 minus 21x, could you combine those guys? No, they're not like terms, just like these guys are not like terms. Questions about that?